10 and welcome to a new topic in chemistry, electrolysis. So do it now. I want you to do your tassamai for the day and then just write down what you think electro might mean and what you think lysis might mean, the two words that make up electrolysis. Pause the video and do it now.
Go.
Hi Year 10. So we're going to look at electrolysis today. I've emailed you this bit of paper which is telling you everything we're going to do between now and the end of term. Whether that's on video or in person, we don't know, but this is what we need to get done. So we're going to be looking at electrolysis today, and there's loads and loads of new words, so we're going to think about what that means. So the first word is electrolysis. I've already asked you to think about this. Electro means from electricity. Okay, so we're going to use electricity in this. And before you say, hang on a minute, electricity is physics, yes, but this is chemistry because lysis meaning split apart. You have lysosomes in biology, which means things that are broken down. So electrolysis is using electricity to split things apart. We are going to split molecules apart. Okay, and that's what electrolysis means, using electricity to split molecules apart. There's a few other words we need to know before I can move on with the lesson. So let's take a look in the book. Okay, now the first word we need to know is electrolytes. So what are electrolytes? You should all know that they're what plants crave, but what are they? Right, it's really simple. Electrolytes are ions that are free to move around. We've got a lovely description here. Recall that electrolytes are ionic compounds in the molten state or dissolved in water. Okay, so we've split them up into their ions. So we've got, sorry, I'm writing this upside down again. Ions free to move. Okay, and what's so special about ions being free to move? That's right, ions that are free to move can conduct electricity just like electrons. Okay, so our electrolytes are going to be able to conduct electricity even though they're not electrons. That's really exciting. So next word, electrodes. Okay, and our electrodes, there's two different ones, the anode and the cathode, which I'm going to come to in a minute. The electrodes are two bits of usually graphite or copper, which are dipped into your electrolyte. So they're going to be put in your electrolyte, and it basically they put the electricity into it, and the electricity moves through your electrolyte and back out the other side. So graphite rods put into the electrolyte. Okay, and there's two of them because as we know we're going to have electricity flowing from one end of the battery to the other. It's a flow of electrons. So if you were thinking here electro was referring to electrons, it kind of is, because electricity is the flow of electrons carrying a charge. And we've got two. We've got the anode and the cathode. Now we've already learnt about anions, which are negative, and cations, which are positive. So if we remember cation, cat or pus, so our cation is positive. Okay, I think you all already know that one. So our two electrodes. I'm not going to make you guess because you might get the wrong one and then you'll remember it the wrong way round forever. So our anion is attracted to our anode, okay, which means our anode has to be positive. Okay, you only have to remember one of these things. So if you remember the cation is positive, then you can remember the cathode that it's attracted to is negative. Okay, another way of remembering this is if you are a fan of Wuthering Heights, you remember Kathy, and Kathy is of course quite negative and runs around weeping and banging on the windows, and Heathcliff, it's me, it's Kathy, I've come home. Honestly, the Kate Bush song was the best thing to come out of that book. So that's how you remember the cathode is negative. Or you can remember that anode is quite a pleasant thing. So if, like me, you've been watching Sir Patrick Stewart read the Shakespeare sonnets, you know that anode is something you can look forward to. It's a positive thing. So let's write this down. So the anode is the positive electrode, and the cathode is the negative electrode. Okay, so to get our heads around this, we're going to think about what's happening. Okay, so we have got, and I'm going to do an example with mollymods here. So I've got here some aluminium oxide. Okay, so what we're going to do is, in this case, we're going to heat it up, and we're going to heat it up to about 1600 degrees C. And when that happens, it takes a lot of energy, as you can see. I can't just do this easily. It takes a lot of energy, but our aluminium oxide splits apart into ions. I'm going to draw this as well if you want to copy my drawing in a second. So there we go. We had aluminium oxide like this. We've now heated it up to 1600, 1800, something like that, degrees C. So it's really, really hot, takes a lot of energy. And we've now got the ions. And these ions, because they are molten, they are liquid, they are able to move. Okay, when they're a solid, they can't move. Okay, so we're going to start by putting electricity through there. And electricity, flow of electrons. So it's going to come out of the cathode first. Okay, these electrons get to this cathode. Okay, so this is the cathode, and it's throwing out electrons. Okay, metal ions, so our aluminium ion here, metal ions are always positive. So that cation is going to be attracted to the cathode, and it's going to suck up the electrons. So it's going to go from being aluminium 3+, we are going to add 3 electrons, and it's going to turn into aluminium, and this is at the cathode. Okay, you only need to be able to do this for the higher paper, so don't worry if you're doing foundation about the half equations. You only need to do them for higher, but I'm showing you this so you can see what's going on. Then we're going to put our anode in. Okay, our anode wants to suck up electrons, but all the electrons have already been sucked up by aluminium, which is now sunk to the bottom as a metal. This is where our oxide ions come in. They are full of, they've got 2 extra electrons, and they're going to move over here. Okay, so the electrons from our anion, our non-metal anion, which is oxide at this point, is going to go and give its electrons to the anode, and that electron's then going to go back and complete the circuit. So they're different electrons, but the circuit doesn't know that, the circuit doesn't care. Okay, and what happens here is, instead of just becoming metal like this, these aren't metal, these are oxygens, and they are going to join together with covalent bonds. They are going to share their electrons, and become an oxygen molecule and go away as gas. Okay, so let's write down what's happening at the positive anode. Okay, we've got oxygen 2 minus. We're going to need 2 of them because, as you can see, oxygen is a diatomic molecule, as in there's 2 of them. And we're going to have 4 electrons because, sorry, that doesn't go there. So we've got 2 oxygen minuses, and we're going to make O2. That's why we needed the 2 there. And each of those have given 2 of their electrons away. So that's 4 electrons on that side. Okay, when you are doing it properly, we're going to need to balance those. As it is, I'm going to leave it like that at the moment because we will go through that a little bit later. Okay, is that making sense? I'm hoping that's making some sort of sense, but it might make more sense if you can actually see it happening. So let's take a look at what I'm about to do. Right. Okay, I've got my safety glasses on, which means we're going to do an experiment. Don't try this one at home because 1, you might not have the equipment, 2, you might poison yourself. This actually could kill you, so we need to be a little bit careful with it. So in this case, we're going to see, this is an ionic compound called sodium chloride. You might recognise it, it's table salt. Okay, now I also have here a small electric circuit, and when we join up the electric circuit, my LED comes on. It's always useful to have an LED to check because then you know what's going on really. All right, so what I'm going to do is I'm going to attach my electrodes. Okay. When you do this at school, we've got crocodile clips to do it. I just don't have the crocodile clips at home. This is very much just what I've got in the house to show you. And when the electrodes touch, you can see that electricity is flowing through it. Great. So I've got my ionic compound. Let's shove the electrodes in. No, it's not doing anything. Oh yeah, that's solid, isn't it? We said earlier that these ions have to be able to move, so they've got to be either in liquid or aqueous state. I wonder if I could heat this up to 2,300 degrees. No, my oven doesn't actually go that high. I can't get molten sodium chloride, but what I can do is I've got a little bit of cool boiled water here. I don't have distilled water at home, so I'm going to use a little bit of cool boiled water and just pour it in here. Okay? And not all the salt's going to dissolve, I know that. Let's just see if I've got something I can stir it with. Just use a ruler. I do have spoons, just not on me at the moment. Okay, so that's most of the salt dissolved now. So, again with the molymods, we've got water, 2 hydrogens and an oxygen, and they're free to move. And then we've got sodium chloride. As a solid, and this is a very basic representation, we know it's a giant lattice. Okay, so we've got sodium and we've got chlorine, sodium chloride, well it's a chloride ion. As soon as they get into water, they split apart, okay? And because they've split apart, they're now not in that giant ionic lattice, they've dissolved nicely, okay, and they're free to move around in the water. So, let's see, I'm hoping this is going to work. What should happen when I put my electrodes in, my anode and my cathode, is we should get this LED lighting up if electricity is being conducted. Let's see. It's Yeah, it should be working. And it's not. Okay. It should do. I'm going to have another go with this a few times before I try and do it for when we really, really need it. Okay, because I should be getting lovely bubbles of chlorine gas coming off my anode, and it's not doing that, and it's not lighting up. Okay, that's fine. We will recheck, we will see what's gone wrong, and I'll make sure it happens properly in another video. Okay, so let's just recap. We have learnt a whole load of new words. We've learnt electrolytes, which are ions that can move around. We've learnt electrodes, which are our graphite rods, or sometimes copper rods, or actually it could be any metal, that we stick in there that conduct the electricity through the electrolyte. We've got anode as the positive electrode and cathode as the negative electrode. Okay, and we've also got anion as a negative ion and a cation as a positive ion. And that's all we're going to do for today. We are going to look at, in future lessons, some specific examples, because you do need to know specific ones. All you need to know is that ions break apart, they move around, and they form the elements. Okay, there is a worksheet for you to do, so I'm looking forward to seeing the results of that. Please do email me with that. Do stay safe, Year 10, and hopefully see you soon. Bye.